Oh yeah, you getting pumped again? Oh, I'm getting pumped. I'm ready for some geometry. Thank you, Moose, for your uprising. It was much appreciated there. Alright, section 1.5, measuring segments, aka measuring awesomeness. That's what we're going to be talking about, how to measure awesomeness. So let's jump into this. If two segments have equal measure, then we call those segments. You're thinking, wait, why we have to call them something else? We've already called them equal. What's wrong with using the term equal? Well, technically in geometry we have another term that lets us talk about two segments where maybe we don't know their exact length, but we can still say that they are, and we know that they are of equal measure. So we're going to call those two terms congruent. Now, congruent and equal, again, pretty much mean the same thing. Equal is in terms of when you kind of know the exact length of something, and congruent is just when you're saying, yeah, they're equal, but I don't necessarily know how long they are. Now, the special way that we would write it is we would just say segment ZX is congruent to segment CV. And geometrically, we have a special symbol for congruent. And the nice thing is, it kind of looks like an equal sign, but it's got the Spanish tilde, if you will, the little, I call it the squiggle, above the equal sign. And this just says that segment ZX is congruent to segment CV. So it is very important now not to forget your symbols. And by the three symbols I mean here are the congruent symbol and the segment symbols that are up top here. Now, if I put line symbols above there, well, lines are infinite in length, so yeah, it's kind of true lines are congruent to other lines because they're infinitely long, but that really doesn't make sense. So make sure you use your segment symbols and not your line symbols, not your ray symbols. So let's talk about what this picture is saying. And some of you are going, oh, this is pretty baby stuff here, Mr. G. AB, it's 3. Duh. BC, it's 5. Well, yeah, okay, that's true. But I'm talking about some other things here. And you might go, well, the whole thing's 8. True, the whole thing is 8, but how do you know the whole thing's 8? Well, duh, Mr. G, you just add 3 plus 5 and that's it. True. That's what we're going to get into. We're going to get into this thing that basically says that if 3 points are collinear, meaning they make a straight line or a straight segment in this case, and if one of those points is between the other two, obvious stuff here, then, and that's why since this is so obvious we call it a postulate, we said that was an accepted truth, then little segment, let's do this, little segment plus other little segment, little seg and little seg, equals the whole segment, or instead of whole we might think of a bigger segment, okay? So AB plus BC altogether makes AC. So there should be no surprise here, okay? But we're going to start to implement this more in a way that maybe you just kind of think about in your mind and you just bypass it. You don't really consider it, okay? So here's an example. Let's draw a line with point C between points H and Y. Then write the segment addition postulate, okay? And we will use this name, the segment addition postulate, specifically later in the second semester when we do proofs. We might have to say, well, we know that this segment plus this segment equals that segment because of the segment addition postulate. So if I wanted to draw a line, let's get a little darker color here. Say, here's my line, and to indicate that it is a line, I need some arrow caps. And I need to draw point C between H and Y. So let's say I just put C right here about in the middle. And then H and Y on the left and the right sides. And you could put the Y over here and the H over there. It really doesn't matter. And then write the segment addition postulate. Well, the segment addition postulate, again, basically said one little segment. So we'll say HC, this guy right here, plus the other little segment here, CY, altogether makes the whole thing. H segment HY. And that's it. That is the segment addition postulate at play. All right, so now let's start to use it a little bit more here. And this first example, you might look at this and go, Mr. G, are you serious? I'm in pre-AP. You know, I'm a smart dude. I'm a smart dudette. EF? You really? EF. What is there some sort of trick behind this? Am I supposed to say like x minus 4 is the length of EF? No, it's 6. It's cool. It's 6. You can see that 10 plus 6 more would make 16, right? No problem, no problem. But this is where You know, what if the 10 and the 16 were x's and they had, what if the 16 was really 2x plus 1 and the 10 was x minus 3 and I want to know the length EF? Then it's going to get a little tougher. So let me show you kind of the really simple way of, the more complex way of doing a simple problem, if you will. Okay? We could say DE plus EF, segments DE plus segment EF equals the whole segment DF, right? And then we're going to start using this idea of substitution. Well, DE I know is 10, and EF is, well, I don't really know what EF is. We know it's 6, but we're going to pretend we don't know that quite yet. And DF, we know the whole thing's 16. So EF is kind of like my x. So if I subtract 10 over to the other side, then I know that EF, the thing that's left, is 6. Okay? And you might think, well, that's kind of a stupid way to do that problem. I could do that in my head. And that's fine. If this is a super easy problem, do it in your head. Knock yourself out. But we will definitely not do easy problems like this in pre-AP. So let's look at 3. Not necessarily something you could easily do in your head like example 2. So if segment AC is 24, okay, we're saying this whole guy right here, AC, that's 24. Then solve for x, and notice there's 3 things I want you to do here. Solve for x, the length of AB, and the length of BC. Okay? So in order to do that, I'm going to start with the segment addition postulate here. I know that AB plus BC, segments AB plus BC, is the same thing as the whole thing AC. And then we're going to use some substitution now. So segment AB, they told me that's 2x minus 1. And add to that BC, which they told me was 8x minus 5, equals AC, and they told me up here, we call that given information, they gave it to us, is 24. And now here we've got a nice algebra problem to solve. So now combining like terms, I got 2x and 8x makes 10x. I got a minus 1 and a minus 5 together makes minus 6 equals 24. I'm going to add the 6 over to the other side, so I'm going to do that without writing it. Would give me 30 now on the other side, and divide the 10 over, and x would be 3. Okay, so there's part 1 of my answer. I can put check mark by x. I have solved for x. X is 3, but I'm not done yet. I also want to know, well, really, how long is A, B, and BC so that when you add them together, you get 24. And how would we get that answer? Well, we take our x equals 3, and we go back and plug it into that x. And we go over here and plug it into that x. So really, I've got 2 times 3 minus 1. Well, that's 6 minus 1, which makes 5. So I'd say the length of AB is 5, which means if I do some quick subtraction in my head, I know that BC needs to be 19, because 5 and 19 makes my 24. I'm just going to double check that real quick. So 8 times 3 minus 5, that makes 24 minus 5, and 24 minus 5 is indeed 19. So now I have solved for all 3 things I'm looking for. Okay, so I would circle those as answers, and I'd circle my x equals 3 as an answer. Okay, and that's how that particular problem works. Now, what if I wanted to put a point exactly in the middle between 2 points? How would I accomplish that? So if I wanted to put point B exactly in the middle between E and K, okay? And I always have fun with this because I'm usually like, all right, I want you guys to tell me when B is exactly in between E and K, okay? And I start moving it slowly, and this seems like some Price is Right game where you're like, oh, it's getting close. It's getting close. Oh, stop. And some people are like, no, a little bit more. And then it's just so much fun because they get in fights about, is B right in the middle? And then I go, you know what? It really doesn't matter. I could put it here, I could put it there, 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 I could put it there. As long as I put some special geometrical symbols in here, it doesn't really matter where B goes. You're just going to have to take my word for it. So we can kind of cheat about certain values by using special markings. And we're going to use things called congruent markings. And the congruent markings say things have equal value, even if it doesn't technically look like it. So, right now I could move B over slightly to the left, and you would clearly go, you know what, EB and BK, they don't look like they're equal at all. It looks like BK is a little bit longer than EB. But if I come along and put congruent markings in there, you can't question it. Congruent markings are basically like a little baby segment. You usually put it right in the middle For example, if I wanted to talk about this segment EB being congruent to this segment BK, then I would usually put my congruent markings right in the middle of those two segments. So these are my congruent markings, that guy and that guy. And technically right now they're saying that segment EB is congruent to segment BK. Even though it doesn't look like it, those markings are saying that they are, and you can't question those markings. Okay? Even if it looked ridiculous, which you won't see that too much, I could put B way over here and say, you know what? This and this, they're congruent. Yep, take that. How do you like that? It's not going to be anything like that. Okay? It's not going to be anything like, whoa, this definitely looks wrong. There definitely will be times where maybe you'll see an angle that looks like it's an obtuse angle, but you get an answer that's an acute angle. And you might question yourself and go, did I really do this problem right? And it just may be that the picture's not drawn accurately, but you just have to go with what you have there. Okay, so yeah, there's my congruent markings. We could write it like this, which basically means congruent to. I remember congruent basically means equal. Now again, we are saying in this case that this segment and this segment, they have equal length, but I'm not telling you exactly how long they are. I'm not saying break out a ruler and let's measure how many inches long or centimeters long these two things are, but these symbols here are telling you that they're equal. You just don't know exactly how long they are. And again, that's when we use more the congruent symbol, more so than the equal symbol. We can also say that point B, in this case, bisects the segment, or the line, if you will. Bisect means to cut into two equal pieces. We said if B is right here, that means that it is splitting EK up into two equal pieces. So we will definitely use the term bisect a lot. Okay, bisect, you can kind of break that word down. Bi means two, and sect means cut. Cut into two equal pieces, if you will. So let's try this one. Now, this time, if you try using the segment addition postulate like we did back in, I think, the third example, it's not really going to work out. And I'll show you why real quick. You might go, all right, RM, yep, plus MT is going to equal the whole thing RT. Yep, this is looking good. RM, that is 5x plus 9. MT, that is 8x minus 36. And RT, well, how long is RT? They didn't tell me up here. And it's not my picture. Oh, well, this is easy. Watch this. RT, it's just these two things added together. So 5x and 8x, that's what, 13x? And plus 9 minus 36, that makes minus 27. Okay, so I can still do this problem, Mr. G. You're just full of it. All right, so let's add like terms over here. I've got 13x and 9 minus 36, that's minus 27. So I've got 13x minus 27 equals 13x minus 27. That's the same thing written on both sides. Well, okay, no problem, no problem. We'll just keep going here. I'm going to add 27 to both sides. And, well, okay. Well, now I got 13x equals 13x. I'm going to move that 13x over to the left side, and that cancels in. Oh boy. Duh, x equals 0, right? That's the answer, x equals 0. But here's the thing, you got rid of all your x's. Technically, this is the answer. 0 equals 0. And you know what? That's a true statement. 0 does equal 0. But that got you nowhere. You didn't get an x equals something. You got rid of it. Okay, so this is why the segment addition postulate in this case doesn't work in this example. You can't do it. You don't know the length of the two segments put together. Now, the other thing to notice here are those congruent symbols. We're saying that segment RM is the same thing as segment MT. So if two things are equal, and this is a mantra, a saying that I like to do a lot in class, that if two things are equal, set them equal. Okay, so all we really got to do, imagine there just being a big equal sign between these two lengths here. The 5x plus 9 is the same length as 8x minus 36. So now let's solve it. Let's subtract the 5x over. Gone. So now we got 9 equals 3x minus 36. I'll add the 36 over to the 9. Gone. And that's going to be what? 45 equals 3x. Divide by 3. And x is 15. Now, is that an answer that I want to circle? Well, let's see. The directions said calculate the lengths of RM, MT, and RT. X really isn't an answer that I'm looking for, but I need to use it to figure out these three answers though. Okay? So let me erase a little bit of this here. So now, if I wanted to figure out the length of RM, okay, I know it's 5x plus 9, but I want a real number here to work with. I just need to take my 15 and plug it into the x. So 5 times 15 plus 9, well 5 times 15 is 75 by my recollection, plus 9 makes 84. So RM, segment RM, equals 84. And that is an answer I can circle. And I'll put a check mark there. I know I've done that problem. Now MT better be the same thing as RM. I better get 84 here. All right? But let's double check. So 8 times 15 minus 36. 8 times 15 is 120. Minus 36 makes 84. That really does work out. So circle that, put check mark. RT is the whole thing. Well, I know RM's 84 and MT's 84, so really the only thing I need to do to get the whole thing, RT is really just 84 plus 84, which is 168. And that'd be the third thing I'd circle. And check mark, I have solved for everything that I was asked to calculate. So it is very important to notice if there are congruent markings in a problem, because that is giving you specific information. If there are not congruent markings there, you cannot put them there unless you know they belong there. Okay?